Well, hello again. What I want to do in this problem is, again, we're going to write down the loop equations, and we're going to use that alternative approach, that alternative convention, and I'm going to write down the node equations. Now, we're going to actually solve this. We're just going to actually, as I say, get our loop equations and node equations, which we could then use to actually solve. So look, what I'm going to do here, first of all, is label my voltages consistent with this current direction. So really, if the current I1 is going this way, our consistency would be plus minus. Current going this way, consistency again is plus minus across that resistor. Current going this way, plus minus. Current going this way, plus minus. Current going this way, that would be a plus minus. This I6 is going this way, so that's a plus minus. Coming on around, going this way, so that's a plus minus. And let's have a look at this. I2 is going in this direction like so, and so that is a plus minus. Okay, I think I've got everything labeled there. All right, so the first thing we can do now is write down our loop equations. All right, so I'm going to basically take this guy right here, and I'm going to call this loop number 1, go in either direction, but I'm going to choose clockwise. All right, so let's write that down. This is the loop 1 equation. All right, we're going to start here. Okay, remember with this alternate approach, basically when I hit the minus here, I'm going to call that a I'm going to call that a minus 5, right? Because I'm hitting the minus first, I actually call that a minus 5. Coming across to the next component, I've got the plus first, so I'm going to say that is a plus. That is an I1 times 1K. Coming on round, I've got the plus first, so that is going to be a plus. That is an I3 times 500. And then I've got the power supply here. What am I hitting first? The minus side of that power supply, so I'm going to call that a minus 10. And then coming on round once again, I'm hitting a minus here, am I not, first? And so that is a minus, and that's an I4 times the 4K. And we're right back at the beginning again, so that is all equal to 0. So that's my first loop equation. All right, next loop equation, we'll call this guy loop number 2. Well, look, let's just go the other way. All right, now where am I going to start? Well, maybe I'll start right here, okay, and I'll look at this first component and so on as we go around. So if I'm starting right here, the first sign I come to is a plus, isn't it? So that's going to be what? It's going to be a plus. The current here is what? It's I2, and that is times 200. All right, next I come to the minus side of the power supply, so I call that a minus 20. Coming on round, I come to a plus here, don't I? So that's a plus, and that is I2 times 2K. Coming on round, once again, I hit a plus here, don't I? So that is a plus, and that's I3 times 500. And then coming to here, I hit the minus sign of that power supply, which is 10, so that's a minus 10. One more component, coming on round, I've got a minus here, so that's a minus, and that would be an I5 times 5K, and that is all equal to 0. So that's my second loop equation. All right, one more loop which exists here. Well, let's go around this guy in a clockwise direction. Okay, so this is loop number 3. So loop 3. All right, let's start here. All right, what do I hit first? I hit the plus sign there, so we're going to say that is a plus. What is the current here? This is an I6, isn't it? So that's an I6 times 400. I hit then a plus, don't I? So that's a plus, and that is an I4, and that is times 4K. Okay, coming on round. I hit a minus here, don't I? So that is a minus, and that is going to be I5 times 5K. Coming on round, I hit a plus, don't I? So that is a plus, and that's going to be an I6 times a 1.5K, And look, I'm back to the beginning, and so all of that is equal to 0. So we now have 3 equations, okay? All right, well, there are several unknowns here. We've got, in fact, 6 currents to find, haven't we? So we've got 3 equations. So what we now have to really do is really look at the node equations. Now I can start with this node over here. I'm simply summing currents into that node. So let's see what's going in, what's coming out. If it's going in, we're going to call it positive. If it's going out, we're going to call it minus. So we've got, what, I1 going in. I've got I2 going in, so that's plus an I2. I3 going out, so it's a minus I3, and all of that is equal to 0. That's one node equation. Okay, let's take maybe this node right here. Okay, what do we have for this guy? Well, let's have a look at this. What's coming in, what's going out? So I've got an I2 going out, so that's a minus I2, isn't it? What else? I've got an I5 going out, so it's a minus I5. And I6 is going out, that's a minus I6. And all of that is equal to 0. So that's that particular node. What about this node over here? All right, let's write down a node equation for that. So what's going in, what's coming out? Well, I3 is going in, so I've got an I3 going in. I4 is going in, so that's a plus I4. I5 is going in, that's a plus I5. That's it, all of that equal to 0. So that's that node. Well, let's now look at this node right here. Once again, what is going in, what's going out? Well, I've got an I6 going in, so that's I6. I1 is going out, so that's a minus I1. I4 is going out, so that's a minus I4, and all of that is equal to 0. Okay, so with the loop equations and the node equations, we really have enough to be able to solve this problem and find out what I1, I2, I3, I4, and I5, and I6 are. And then once we know the currents, we can find everything else in that particular circuit. Now, we're not going to do that. The circuit analysis part of this really was coming up with these equations. The rest is just really mathematics, and there are various ways that we could actually do that. And really, this is a repeat of a problem that we've looked at before. The only difference here is we're looking at basically this alternate way of summing the voltages around these loops. Okay, so I hope this slightly more involved problem really helps. And look, I'll see you next time.